Good morning, everyone. How are you? I hope to be fine all the time. Today we will discuss a new lesson in the Unit 3 for Secondary 1 first term. This lesson talk about the collective properties of solutions. Remember again, solution is a homogeneous mixture. A homogeneous mixture consists of two or more substances mixed together without any chemical reactions, but the components of this mixture cannot be seen by naked eye or by electronic configuration because the size of these particles is very small. The collective properties means the properties which depend on the number of particles in the solution, not on the type of these particles. This means what? Particles of sugar, like the particles of salt, and the effect of these properties. No difference between them as they differ in its type, but if they present with the same number of particles, so the same effect in the collective properties will be occurred. Again, to determine or to define the collective properties, we can remember that the collective properties, it is the properties which depend on the particles, the number of particles of substance, not on the type of these particles. Okay, we will discuss three properties here. The three properties, they are vapor pressure, the depression in the vapor pressure, elevation in the boiling point, and the depression in freezing point. So, to understand the concept of collective properties, or what is the meaning of collective properties, we can see this video, then complete our session.
It's going to be on colligative properties. Okay, colligative properties. What the heck is a colligative property? Well, a colligative property depends on the concentration of solute particles. Okay, depends on the concentration of solid particles, not their identity. Okay, so if we put more particles in, that property changes. That physical or chemical property will change. That's known as a colligative property. Okay, the types of colligative properties that we're concerned with in Chemistry 1 is the freezing point depression. That states that a freezing point of a solution is lower than that of pure solvent. So that means you add something to this mixture, and instead of freezing at, say, 90 degrees Celsius, it freezes at 80 degrees Celsius. So it lowers the freezing point. Okay? Lowers the freezing point. Boiling point elevation is as you add some substance to another substance. That boiling point is higher than the actual boiling point. For example, water. If you add salt to water, it actually will boil at a higher temperature than 212 degrees Fahrenheit to 100 degrees Celsius. Same thing with freezing. If you add salt to water and try to freeze it, it's not going to be frozen at 32 degrees. It's actually, depending on how much salt is in it, going to be a little bit lower than 32 degrees. So that keeps the state of the ice, or instead of being in the solid form, it stays in the liquid form at a much lower temperature. Okay, so this is what's actually happening. Say we have some water molecules in this system. We'll call this box a system. All right, water we know is a solvent. When it is pure, water freezes at 0 degrees Celsius and boils at 100 degrees Celsius. But if we add something like, for example, we've added some ions in here. These ions actually go and disturb the intermolecular forces that keep the water molecules held together, that are attracting these water molecules. Now, an intermolecular force is a force or attractive forces between molecules. So notice how it's breaking some of these intermolecular forces. Instead of the positively charged oxygen of one water molecule being um, somewhat attached, or somewhat attracted rather, to the positively charged hydrogen molecule of the next molecule, those ions are breaking that attraction up. It's changing the charge in there. So what actually happens is the intermolecular forces are what cause the pure substance to either freeze or boil. Since you do not have these strong intermolecular forces, it's going to take longer for this to freeze. So that's why the freezing point is actually lower. And kind of the same things happens with boiling point. Okay, if we put in regular water, we start to boil it, it's going to boil at 100 degrees. But if we put in some sugar molecules or a sucrose molecule into this mixture, it won't boil at 100 degrees. It'll actually go a little warmer. That's because the sucrose molecules are affecting the intermolecular attractions between these water molecules, and the vapor pressure is actually a little bit lower. So it takes a little more temperature when you have this in the mix to make it uh, boil. So you may boil at 110, say, degrees Celsius. Now, applications. Where would we apply this? Salting icy roads. Well, if we add salt to bridges and different things like that, um, that actually will cause the ice that's on these bridges to melt. Okay? When they melt, that allows safer travel across the bridges. Also, when making ice cream, if you've ever made ice cream at home, we're actually going to do that in this class. If you make ice cream and you put salt in your ice cream freezer, that actually makes that water, that ice, colder. It allows it to get much colder than 32 degrees. Which, if the outside, the ice around the barrel or whatever you're using to make your ice cream, is colder than 32, it allows what's on the inside, your milk and things like that, the liquid inside that, to actually freeze. Uh, we also use boiling point elevation and freezing point depression in antifreeze for cars and both fish and insects. Cars, if you put regular water in your car and it gets to 32 degrees one night, well, you run a risk of that water in your radiator freezing and cracking your radiator. Now, what
Again, we will come back to our session. As we show now in this video, the collective properties depend on the two main property of any molecules. First property, it is the attraction force between the molecules and the continuous free motion of these molecules. In the case of pure solvent, if we put some pure solvent in a closed system, what is the meaning of closed system? It is a system allow the exchange of heat or energy, but not allow the exchange of matter. So the molecules of pure solvent attract each other. Also, they are in continuous free motion. So the molecules of the surface will liberate from the attraction force and go to the surrounding area, free area, which means it is make an a vaporization process. So more and more molecules of pure solvent, for example water, will go up as a water vapor in the surrounding medium around the pure solvent until this area or this medium saturate with the molecules of pure solvent of water. In this case, the rate of vaporization will equal the rate of condensation. Some molecules go up and some in the same number of molecules go down, which verify an equilibrium, dynamic equilibrium. Dynamic means movement in both direction, up as a vapor, down as condensation process. Equilibrium, the number or the rate of go up equal the rate of go down. The rate of vaporization equal the rate of condensation. In this case, when this vapor pressure equal the atmospheric pressure, this means the pure solvent will boil. Okay. So the vapor pressure, it is the pressure that affects the liquid surface when the vapor is at dynamic equilibrium, which with its liquid inside the closed container at constant temperature and pressure. Again, be careful, this value of vapor pressure must be at constant temperature and pressure, because any change in these factors or these conditions, temperature or pressure, will change the value of vapor pressure. Here, a figure illustrates the pure solvent and the attraction force of the surface molecules, which some of them evaporate and go up as a vapor, while when we add any solute for this solvent, the distribution of the particles or ions of this solute will increase the attraction force between the solute particles and solvent particles, which make a limitation for the vaporization of solvent particles up. This means the number of molecules of solvent which vaporize will be less. This means the vapor pressure as a whole at the same temperature and the same pressure will decrease from the pure solvent. So our conclusion, the solution has lower vapor pressure than the pure solvent at certain temperature and certain pressure. This is also an apparatus used to measure the vapor pressure of pure solvent and the vapor pressure of a solution. Now we will transfer for the point of the elevation of boiling point. As we mentioned before, any solvent to be boiled must its vapor pressure equal the atmospheric pressure, surrounding atmospheric pressure. If the vapor pressure decreases by the effect of the presence of some solid particles in this solvent, this means we need more energy or more temperature, higher temperature, to reach to the vapor pressure which equal the atmospheric pressure. This means the elevation in the boiling point. Be careful, there are two boiling point, two expressions for boiling point. The first one is the natural or normal boiling point. It is the temperature at which the vapor pressure of the liquid equals the atmospheric pressure. Measured by thermometer, it is the temperature at which the vapor pressure of the liquid equals the pressure exerted or acted on it. Here, a graph illustrates the relation between the vapor pressure of water and both the boiling point of the water and solution. This is x-axis for temperature, y-axis for vapor pressure. The pure water will be boiled at the pure water will be boiled as seen here at 10 degrees Celsius, while the solution, aqueous solution of any substance, has higher boiling point. This is why, because the vapor pressure of pure water is higher than the vapor pressure of solution at the same temperature and pressure. Now we will transfer to the third colligative properties, which is depression of freezing point. The freezing point of the solution is always less than the freezing point of pure solvent, which form it as the attraction force between the solvent molecules and the solute molecules in the solution hinder the conversion of solvent from liquid state to solid state to form a crystal. This means what? As we said before, there are attraction force between the molecules of solvent. This attraction force is the cause to form certain crystal at freezing point. If we add a new particles of a solid, these particles will occupy the distance or the spaces between the solvent molecules. So it will make some troubles or some effect which prevent the attraction or less the attraction force between the solvent molecules, which leads to, if we lower the temperature to form or to reach the freezing point, this will need more lower temperature to reach to the freezing point. So as a conclusion, the freezing point of a solution is less than the freezing point of pure solvent. Here an application which illustrate that the number of molecules or the number of moles of solid will affect the colligative properties, not the type of these molecules or particles. Here we have two solutions. The first one is glucose solution. The second one is sodium chloride solution or salt solution. One of them has 1 molar concentration. Okay, 1 molar concentration means 1 mole of glucose and 1 mole of sodium hydroxide in a certain amount of water or solution. But here, glucose solution will, when dissolved in the water, its particles became intact. No dissociation or ionization occurred on it. So 1 mole of glucose remain as it is 1 mole of glucose particles. But the sodium chloride, when dissolved in the solution, the 1 mole of sodium chloride will dissociate or ionized to give 1 mole of sodium ions plus 1 mole of chloride ions. This means 1 mole of sodium chloride give us 2 moles of particles. So the boiling point of sodium chloride solution is higher than glucose solution. Why? Because the number of moles or the number of particles in sodium chloride solution higher than that of glucose particles in glucose solution. Also, the freezing point of sodium chloride solution will be less or more lower than the freezing point of glucose solution. Why? Because the number of moles or the number of particles of sodium chloride in its solution is higher than the number of molecules or particles of glucose in its solution. Okay. Here there are a relationship to calculate the freezing point of electrolytic solution. Again, remember that electrolytic solution means that the particles or the molecules of this electrolyte solution are ionized or dissociate to its ion when dissolved in a water. But non-electrolytic solution or non-electrolytes, they are not dissociate or not ionized in the solvent when dissolved it. So the relationship is the freezing point of electrolytic solution equal in number of moles of ions, again of ions which produced after dissolving process, multiplied by negative 1.86 degrees Celsius. Here an application for this rule. What is the freezing point of the solution that contain 1 mole of calcium chloride in 1,000 grams of water? Firstly, we must write the chemical equation which illustrate the ionization process of this salt, here calcium chloride. When put calcium chloride solid 1 mole in a water, this calcium chloride will be dissociated into 1 mole of calcium ion, positive calcium ion, and 2 mole of negative chloride ion. This means 1 mole of solid calcium chloride give us 3 moles of ions. So by apply the relation which discussed before, we will multiply 3 moles of ions by negative 1.86. So the freezing point of the electrolytic solution will be decreased. This is the difference in the freezing point depression will decrease by negative 5.58 degrees Celsius. Here, as a conclusion, to compare the 3 colligative properties and its value in solution and its pure solvent. Vapor pressure in solution is less than the vapor pressure in pure solvent, while boiling point of solution is higher than the boiling point of pure solvent, and freezing point of solution also is less than the freezing point of pure solvent. And this is a graph illustrate the relation between temperature and pressure and the elevation in boiling point, depression, and in freezing point. Okay, for sure it is clear that pure water have higher vapor pressure and lower boiling point and higher freezing point in comparison with its solution. So this is the end of our lesson today. Thank you for your attention and goodbye.